Welcome, my name's John Galloway. I'm a PM on the, we keep getting reorg, but I work with dev community stuff at Microsoft, so we'll just keep it at that. So I'm gonna be talking to you about intelligent .NET apps, moving from like the simple cases, getting started, up through agentic systems. To clarify, Microsoft talks about AI a lot. A lot of the time, they're selling you AI products. Here's how to use AI to build things. I use them a lot, so I can't help but like mention a few, but the focus here is on you building things that use AI, right? Not using AI to build things. Just to level set, to get started, who here is like actually shipping code to production that is using like Microsoft extensions for AI, Microsoft agent framework, stuff like that? Okay, not so many though. That's fine. You're in the right place. You'll learn stuff too. And then who here is like no idea what's going on, maybe even in the wrong room, like what the heck is all this? Okay, good. All right, welcome. Cool, all right, let's dig in. So here is what we're gonna be covering. So we'll start with the building blocks. What do we got to help you build stuff with AI and .NET? So we'll talk about Microsoft extensions for AI. We'll talk about vector data and embeddings. We'll look at reg and look at some demos that we've got with templates to help you build with reg patterns. And then we'll look at Copilot SDK. Just a short little like ad for, because that's a late dropping thing, but it really helps you to be productive fast. Building AI solutions on top of Copilot CLI in this weird way that kind of works. We'll talk about Model Context Protocol. That is a way to move from these building blocks to kind of more advanced systems. So those really kind of help build tools. They wrap SDKs and things like that in ways that LLMs can call them, help you building up to the third thing, which is agentic frameworks. So this is your multi-agent workflows and your bigger, more advanced stuff. I got some slides, but I also have some fun demos that'll kind of hopefully pull this all together. So we'll get started with Microsoft extensions for AI. As Microsoft often does, we wrap a lot of stuff, complicated stuff together. Sure, you can go down and write at the bits and bytes level, but we make it easier for you to actually build things at a higher level of abstraction. I think of this as entity framework for AI, right? So you could go and talk directly to all these different SDKs and things like that, or you can talk kind of at a higher level of abstraction, digging down as deep as you want when you want to, right? So you're not kept from using anything, but you're able to write kind of more higher level code, right? So here's where we see this, like we're talking, your app in the upper left corner is talking to an iChat client, running middleware. Those are all standard things. Those are all just straight up .NET code, lists and stuff like that that you're used to. And then down at the bottom, we're talking to a bunch of different providers. So just like EF, talking to a lot of different databases, right? So your code is portable. And your code, it's not just about your code being like, oh, I'm going to switch providers, although you definitely can, maybe more than you can with EF. Thanks for the light dimmer. But it's that the concepts, you don't have to relearn everything. It's like, oh, I was writing stuff for OpenAI, now I want to write for Anthropic or Llama or whatever. You don't have to relearn anything. Your code and your libraries and all that stuff stays the same. So if you're writing directly to OpenAI, so this is an example writing to the OpenAI, you've got to learn the systems, right? You've got to learn all the different calls, get what to install, how to parse the JSON, all that kind of stuff. With MEAI, you're using an iChat client. So this looks like the same amount of code, but this is actually the same thing written 3 times, right? We got our Ollama at the top. Ollama is great for if you're running code that runs on local hardware, if you've got powerful GPUs. This is good for 2 cases. You're a developer, you've got a good enough GPU because you're a gamer at night, and you're able to like run your LLMs locally, right? Or for like enterprise systems, things that can't connect to the internet, you're actually able to run LLMs against Ollama or other things like that. So that's your iChat client running against Ollama. We switch it out and we say, oh, now I want to run with the OpenAI client. So instead of the Ollama API, let me see if this works. No, it doesn't. Instead of using the Ollama API client at the top, we're using the OpenAI client, right? So you can just switch those out. We're actually spinning up some things to make it easier. We're like a community effort to contribute to other, because this iChat client is just a common interface, right? So these also work with structured data. A lot of the time, you're going to be getting JSON back. You're going to be sending JSON, you're getting JSON back. The kind of real simple case when you get started is just a bunch of text, and that gets really hard to work with. You actually, a lot of the time, are going to want structured data that actually you can like bind to or you can trust, to actually be formatted and have all the fields you need and all that. Parsing JSON is a pain. Constructing JSON is a pain. So that is a big thing that these things give you. MEAI handles automatically like mapping to models, and you can just say like, go get this, get me a list of chat or of product responses or something like that, and those are enforced. So what's cool is down at the protocol level, we'll say to the LLM, hey, give this back in this format. We'll validate it when it comes back. We make sure, so by the time it gets to your code, it's valid JSON. This slimmed out a lot of, when I started using this, cut out a lot of just stupid code, right? All this JSON juggling and parsing and all that stuff, right? So yeah, so you're actually, we've got lists of classes, and then we just say get response async of a family, and it's mapped, right? So those collections. So nested, all that kind of stuff handled for you. Another nice thing that MEAI does for you is middleware. This is your standard. If you've built like, especially with ASP.NET, you're used to middleware for things like, caching and validation and all that sort of stuff, right? And so that same sort of middleware thing that works for you works here as well, right? So you can plug it in, and also it's not a new concept to learn. Rate limiting is a great example. When those tokens cost money, you don't want to keep pounding a thing with the same thing. Maybe we cache it and rate limit it. Also, another really important thing is content safety, right? Because we're getting back data, we want to make sure that what's going in and what's coming back are actually quality and safe for presenting to users. Another big thing is open telemetry. When you're working with these systems, you need to understand what's going on. What was the prompt that was sent? Sometimes if it's constructed by an agent or something, we don't know. Open telemetry helps you diagnose that. All this stuff is included in this middleware pipeline, right? So if you're hand rolling stuff, don't, because it's a waste of time and you're losing these cool features. Another neat thing, content types. So you'll see all the time we talk about chat and we talk about text. That's because it's simple. It's easiest to demonstrate, it's easiest to explain, but it's important to also have ability to handle multimodal. So this is things like files. Our example that we have uses like PDF files, but also things like URI content, using image data, etc. So that's an example of that. But the general idea here is, thinking bigger. It's not just about generate some text or summarize some text. It's also, hey, look at this image and tell me what's in here. So thinking about this, I talk to people regularly at conferences like this, and they're saying, hey, we've got this huge catalog of products, and it's in PDF files, and there's pictures, and it's not even really well formed. You can both destructure that, break it apart, and then you can use AI to say, analyze these, and what actually is in these photos. Is it perfect? No, but it gets you a lot closer, right? So those are kind of the building blocks. Before I go further, let me show you what I promised, which is, so if we look, this is the .NET blog. I know it's all of your home pages. It should be, because there's a lot of great stuff on here. We just posted a thing today about this multi-agent voice bot. It was a guest post. It was really cool because it's real-time voice stuff. But the post series I'm going to show you here, there's this one here and this one here, and these are by Jeremy Lickness, AI PM on the .NET team, and he's got this series going where he's breaking down the core building blocks. So I'm rushing through these kind of fast. I made sure to actually use the same code samples that he's using in his. So he's kind of, this is where you can go to actually read deeper and kind of go like, I didn't get that one part about the multimodal. That's where this is, okay? So great series here. There's this, and then there's also vector data. So vector data was the thing that I went through pretty quick, but talking about like structured data and mapping data and what we can do with that data. There's great opportunities for things like vector databases as well. So indexing and being able to similarity search, those sorts of things. And so he also has a series going through this as well. So what's cool about vector data and a lot of things here is the naive way of working with AI is just saying, here's a bunch of text, give me a thing back. And that's really expensive. It's like on the one hand, it's who knows about the quality, who knows what you're going to get back, right? But it's also expensive because everything you do with AI costs tokens, and those tokens are expensive, especially if you're using good models. So there's a lot of things you can do using good, engineering practices to think about what are good problems to solve for an LLM and what are good problems to solve otherwise. So vector data is a great example where you can say, hey, I'm going to take my product database, throw it into a vector database like Quadrant, and then I'm going to say, I want similarity searching. So then you can tell your LLM, hey, here's my vector database. If you want similarity search, go look it up in here. And then it's not going through and parsing all this stuff and saying, I think a hat is kind of like a shovel or whatever, right? It's actually just going directly to the vector database, which is indexed and doesn't use any AI tokens and can look that up. Okay, so vector data, hooking these things together is a great way to get better quality and also to save money. All right, so popping back in, we're going to put all this together with some demos quite soon. So RAG, retrieval augmented generation. I always blank on that, but pretty sure that's right. A lot of the time you are querying an AI, a large language model. And we all ran into things early on where we said, hey, how do I do this in .NET? And the early large language models were trained a while ago, and it would say, oh, that's not available in .NET. The latest version of .NET is .NET 6, and it only has blah, 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 right? That's because a large language model, you can think of it as it's learned everything it's going to learn, it's sealed off, it's done, right? It's basically like a zip file or something, right? It's all this information, the training's finished, and it's not going to learn anything more. So the way that LLMs work around that is by looking up information, just like we do. If someone asks us a question we don't know, we hit Wikipedia or Bing or Google or whatever, right? Okay, so that's an example of augmenting what it knows with more stuff. Now what's cool is we can hook in more stuff. We can say, hey, here's how to look up stuff in our product catalog. Here's how to look up stuff in our SharePoint. Here's how to find things, right? And so this is a way where we augment what it's got available. So that we can do this using a lot of patterns, but a lot of time there's this kind of back and forth where you'll type into a chat. The chat will say, I think the user is asking about products. It wants to know what are similar products to this spaghetti. And then it calls back into our program and says, hey, I need some help, find me products similar to spaghetti. And then we call into our vector database because we're smart and we index this data. And then we pass this stuff back. And then the large language model compiles it all together and says, I got your answer. And it replies to the user using all that information synthesized together. All right? It sounds like a lot, but just think of how you work. Someone asks you a question, you don't know, you look it up, you get the information, you put it together, and then you send it back, right? So it's the same exact workflow there. Vector data, we've talked all around this. The one other thing I want to point out about this, I've mentioned Quadrant a bunch. I love Quadrant. It's open source. They have a paid hosted model available, but you can just run it in Docker. It's pretty cool. But there's other things out there. There's Redis, SQL Server. A lot of you have data in SQL Server. Did you know SQL Server has great vector data capabilities? So that means you can index on vector data, you can similarity search, you can do all kinds of cool stuff. Davide Mauri at Microsoft does a lot of talks on this. You can look up his blog posts, etc. So if you've got information in SQL Server, don't think you need to get it out and get it into some other vector database. You can use SQL Server today. There's Cosmos and Azure AI Search. Awesome for like you flip a switch and it's already running for you in the cloud, and so that's a great solution too. Also with those, you've got your governance that you've got in Azure, right? So again, the whole thing with this vector data AI, API is you're writing against the same things. You're writing classes that say, hey, this is vector data, this is the key, this is whatever, and the vector, it's Microsoft Extensions for Vector Data, I believe, my MEVD. That is what kind of hooks that up. And I got it right. It is Microsoft. I didn't cheat it. And look at that. Microsoft Extensions for Vector Data. So it's this common thing. You just say, this is my key. This is some data. Now, here's an interesting thing. Down at the bottom is where you do some kind of magic stuff where you say, hey, vector database, this is how you find things that are similar. We're going to use cosine similarity, which is a common algorithm for figuring out things in vectors, what vectors are closer to each other. And 1536 is the number that people agreed on, and we just put that in our code. So, so this is an example of writing very similar to like an entity framework model. This is your vector data model. I usually create a separate one. Like I don't try and create one big model and blah. I actually create like mapping things, and I say from this, and I'll create like a mapping. I'll say get me this from this, etc. So there's different ways to do this, but this is how you do your vector data. Okay. So first of all, I want to show this AI chat with custom data. So if I go File, New Project, this is on my list of things that I can create. So I'll say I want to do AI. I'll do an AI chat web app. If you don't have this, you need to install these templates. That's super easy to do. You do, let's go into here, .NET new install. Well, it's a command. Do I not have it? I don't have it open. You look in the docs or whatever, but it's .NET new install, and then it's like the string for it, Microsoft.Extensions.AI, whatever. So we give it a name. Now here's the important things is, okay, whoa, mega zoom, and an offer to help me out with something that I didn't need. Okay, you can pick your framework. You can say which AI provider. Now remember, iChat client and MEAI works with different providers. So GitHub Models is free, included with your GitHub subscription. So you can use more advanced things, but there's a lot of stuff that's just available for free. You can also use Azure OpenAI, of course, if you have an Azure subscription. You can use Ollama. So Ollama is this platform for running locally, super slow unless you've got like a powerful GPU. Even then, it's not going to be as fast as cloud hosted, but it's great for testing, and then also great for like, hey, I've got data I don't want going off into the cloud or whatever, right? Or you can develop directly against the OpenAI platform. Or you can create with any of these and then swap it out in your code because it's all switchable code. Then you can say use Aspire for orchestration, which I recommend, and I'll show you why in a second. All right, so I've done that. I did File, New Project. And when it pops open, it's going to give you a README. And if you're like me, you close these right away. But I recommend you don't do that because this actually has important information in here. So this tells you how to configure your thing. You need to set up a connection string. So what I did here is I decided to use GitHub. I went over to GitHub, created a new token. Pretty quick to do. So the way you do that, you do like GitHub. Switching back and forth, so I'm not going to worry, but it's GitHub and then settings and developer and stuff. I pasted them into my secrets JSON. So to do that, I do right click, manage user secrets, and that pops open that. Little side advertisement. always use user secrets. Don't put your API keys, don't put your, any of your keys, connection strings, etc. in your code. There shouldn't be strings, and they shouldn't even really go in app settings. User secrets actually is separately. It's stored with your user profile. And so even if you like forget about git ignore, whatever, there's no way that you're actually going to publish this with your code. So you should always use user secrets. Really important developing with AI. Okay, so we're just going to run this real quick. So when I set this up, I said use Aspire. So I'm using Aspire for orchestration. I do need to have, funny, it's showing my taskbar from my main computer, and I'm working in a dev box, and so I can't switch between things, which is a little quirky. Okay, so it's using Aspire for orchestration, so that's really useful. The reason is because it allows me to kind of see all the stuff, see it as it's spinning up. Here's our chat thing. So what this is doing is it's loading information from PDFs. So it's pulling a bunch of PDF information in. This is a product database. So if I say, do you have a watch? I know it has a watch because it ingested this data. So one of those product catalogs that it read in was a watch. And so it says, do you have watches? Do you? Oh, it's still ingesting the data. Yes. Okay. So yes, there's a watch. And then is it waterproof? I don't know. It doesn't know. Okay. Does it have GPS? Let's give it an easy one. It's a GPS watch. It does have GPS. Oh my goodness. Okay, and if we click on here, it'll actually take us in, and it links directly to things in there, right? So this is an example where we're ingesting a bunch of PDFs. Now we can actually see that flow if we look in Azure, or I mean in Aspire, at the traces. And I think if I filter this, there's like stuff in here where it like read it in using Markdown service. It put it in a vector database. So this is, I told it to use Quadrant, actually stored that data in Quadrant. So then we can look for similar products, and our reg chat is able to call into that, right? So I really recommend this. We've done whole like workshops on this. It's really, like, here's an example when I did my query, and there's a lot going on, but here this actually shows it. Aspire kind of composes that all together. And it'll show you in here where it's doing different things to call against, well, here, let's ask it to explain itself. Explain that trace, here's what it did. So this is a nice feature in Aspire where it can actually go through and understand stuff and explain it based on the entire trace. Right? So this is using GPT-4o Mini. Probably need to bump that up to actually get useful results, but there you go. One other neat thing is, if I go into I'll go back to my, I guess, traces. I'll look at one of my recent traces. Because it's Blazor, a lot of these things are like keep alive. There's one. There. So we'll look at this. Now, a neat feature, remember I told you like a neat feature of MEAI and Aspire are that they all understand OpenTelemetry. And here's a great example of how that helps us out. Sometimes when we're working in these, like there's orchestration, there's all these different things are composing and changing the prompts, what actually even got called? So there I clicked on the little sparkle here, and that actually tells me here's the exact prompt. Here's what I typed, do you have a watch? But there was actually a system prompt that went in ahead of time, right? So this makes it a lot easier to kind of understand what's going on. And then you'll see at the very end, here's the output, right? Here, this is, I think they call those icebreakers. So the idea here is when it says like, do you have another question? You know, like AI loves to do. So here we can kind of trace through. Here's what it returned to us. Here was my thing, system prompt, all that stuff. So highly recommend as you're digging in, getting started, building solutions, AI web chat template and MEAI to kind of simplify things. Don't go down the rabbit hole of picking, I've got to pick my provider first, and I've got to learn all this thing, and I've got to do all that, because a lot of that is not really useful. Now, we can also, so some of the things here, first of all, in our web app, so I'll start with the Aspire solution. So Aspire, very simple, standard stuff. It's just hooking everything together, right? That's what I love about Aspire. It makes it easy to compose complex things together. Here's my web app, and you'll see in my web app, okay, this looks a bit like a lot of code, but it's not too bad. A lot of this is, it's a web app. It's hooking up the web app. Now here, we're saying, this is MEAI in action. We're saying create a new Azure OpenAI client. Now, that's confusing because we're using GitHub models, but GitHub models, spoiler alert, GitHub is actually owned by Microsoft and Azure, and they work together. People actually talk to each other, and they said, hey, let's use the same model for this. So the Azure OpenAI client works with GitHub models as well. Question? Relationship between MEAI and semantic kernel. I'll get to that a little bit later on, but a way of thinking, so basically semantic kernel and autogen have kind of folded into Microsoft Agent Framework. So MEAI solves kind of more the building block level, the kind of lower down. Semantic kernel is essentially, we're kind of recommending if you've got stuff on semantic kernel, you should look at MEAI and Microsoft Agent Framework going forward. So there's a lot of people built things, and we really tried to focus on like, hey, let's converge things together to, just a few things. So yeah.
Earlier you mentioned that there would be connection strength in the code, especially when using AI.
Mm-hmm.
Talk a little more about that. What about AI? Say where you test environment.
I recommend never putting connection strings in code ever.
Okay, nothing to do with AI, just as general.
Just never, ever, ever. Yeah, like I taught. Yeah. So and the reason why is it's so easy to do, right? So you right click on the project, you say manage user secrets. Here's your file. It's a JSON file. Everything in all through .NET knows how to read this stuff. So it's able to read these things. Here it says add a connection string. It's able to read it directly. So Aspire is plumbed with it, right? And then if we look in here, like this is plumbed. Everything is kind of plumbed to be able to do that. Now the magic of this is there's this JSON file that only lives on my machine. So what happens when I deploy to production, right? Well, all of .NET is set up to work with looking for environment variables. So if it's in Azure, it can look for your environment variables in Azure, right? If it's in Docker, it works with Docker. So everything all through .NET, like they worked really hard on this. And so it's a trap to fall into, because when you read sample code for AI, it always is like, paste your API key here, paste your this there, and then you search GitHub and it's just full of all these API keys and people are spending your money, right? So it's not good. So anyhow, so thank you very much for asking about that. So here's our general kind of setup code. In here, we're saying, hey, add a quadrant vector store. We're spinning up the app. There's a thing in here then later where we say, hey, let's go ahead and do ingestion. And ingestion is this process where we process all these PDFs and turn it into text, load it into our database, etc. So I'm going to look quickly at this, but I really do need to move ahead because we still got to get to agents and other stuff. So if we look at stuff like, I think here, like here's an ingested chunk. That sounds like maybe lunch didn't go down well, but so this is an example of vector data. So we've got our annotations on here, right? And we're saying, hey, annotate this. This is our vector store key. This is blah, blah, blah. So this is an example of annotating in a way that then it can be easily stored and parsed and all that kind of stuff. Here's our semantic search, and we're able to say like, hey, go find this thing in our vector collection. So, I'll show you one more other thing in here, which is in the web app. If we look at our page, if we look at chat, and if we look at, I think it's this one. Yeah. So this is where a lot of the actual code of the, like, surprisingly, a lot of this is just rendering stuff onto the screen. We create this function factory. We say, hey, here's a new chat message. And then we say, so an interesting thing about talking to a large language model is it's essentially stateless. So this is kind of like when you're talking to a REST service and you kind of have to say like, hey, I'm this user, remember, somebody's got to store that state, right? Do we pass some state back and forth? Does the server store information, whatever? Well, large language model, like I said, it's like a zip file, it's sealed. It's every time you talk to it, it's waking up and saying, hi there, what do you want, right? And so we've got to pass the context to it. So when we are continuing our chat and we keep saying like, hey, tell me more about that watch, is it waterproof if I hit it with a hammer? Like if I keep talking to it, we've got it shouldn't say is what waterproof. It needs to know we're talking about a watch, right? So you'll see this is very common when we're talking to a large language model is we loop through or we do something, we build up this state and we add them to our query. So then we say like, hey, go get me the, here is everything we talked about. Here's my latest question. And then look it up async and it gets the thing back, right? So here's all this stuff about resetting and all that. So if you are completely new, you want to start writing some .NET code, this is the place to start, I think, is with these templates and with MEAI. Okay, I'm going to talk quickly about GitHub Copilot SDK because it is another thing you can use. And while MEAI is pretty simple, you still have to fill in your endpoints and your keys and all that sort of stuff. Copilot works in some very specific scenarios. If you've got Copilot running on your computer, the Copilot CLI running on, does anyone use Copilot CLI on their computer? Cool, all right, some other, yeah? Okay, I'm having so much fun with it. If I talk fast enough, I'll show you a quick little demo. But Copilot CLI is really a local developer tool. It runs on your machine. It uses your logged in subscription to GitHub and it talks to GitHub Copilot and it gets stuff back. So that is the Copilot CLI. Then they said, hey, this is cool, but I want to be able to script it. I want to be able to do this and that and this and that. Well, they keep adding tons of features to the Copilot CLI, but there's some things in order to make it like scriptable and things like that, you need an SDK. So what they essentially did is write this SDK that it's .NET code, similar to your iChat client. In fact, there is an iChat client way to hook this up. You talk to it, you ask it questions, and it's actually asking your GitHub Copilot logged in subscription, the things, right? So that's cool for a lot of mostly developer sort of scenarios. It's not going to be great for hey, your company is going to deploy it because do you want your entire company doing product queries and serving production data off of Joe in IT's Copilot GitHub license, right? It's kind of, so it's maybe, I don't know, but so it's kind of less of a, MEAI is kind of your writing production code, running against Microsoft, Azure OpenAI, like Azure Foundry, like that sort of stuff, right? Microsoft Foundry, keeping up with the branding. So, but GitHub Copilot is great for doing a lot of specific cases. Okay, so we've got the Copilot CLI, super fun. We've got this SDK essentially just wraps that, right? So you've got, it's interactive, it's headless, you can use it in MCP scenarios, all kinds of stuff there. So When do you use it? Now this is comparing the CLI versus the SDK. The CLI is interactive. I'm typing this, I'm giving instructions, I'm saying, hey, review this file, create a pull request, that sort of stuff. The SDK is more, if I want to do, say, processing, scheduled tasks, batches, tools, things like that. Okay. You can integrate it into applications. Again, yes, and always think about, if you're using the GitHub Copilot SDK, that it is using JSON RPC and it's running Copilot CLI on your machine. Okay, so you don't get that whole scale and all that, like governance and all that. That's out the window. Okay, talking about the authentication model. So the standard case is it's running on your logged in GitHub identity. You can use OAuth. Again, OAuth is really kind of tied to at the user level, but you can run it against GitHub OAuth. Now here's where things get a little interesting, because I've had this argument with people at work, and they'll be like, oh, wait a minute. This actually does work for some consumer scenarios because we can use BYOK, which is bring your own key. So there actually are docs in there where you can say, hey, I want to use GitHub Copilot SDK, work great on my machine, let's ship it, and you can actually point it to an endpoint. You can say, here's my endpoint, here's my API key, and you can use that. So now it sounds like we're building competing things, but really this all still works with iChat client as well. It's like sometimes different scenarios grow up to kind of get interrelated. So you'll notice about your Copilot SDK code, it's super simple because there's nothing in here about authentication or keys or any of that sort of stuff. It's like, assume we have Copilot CLI working on this machine. If we don't, then just die. It's give up, right? So all you're doing is picking the model. You can do some other things like handling different events, but it's super, super simple, okay? So talking about the 99% of the time, you're just doing the SDK running against the CLI on that machine. You can, if you want to run it in production, you can have, hey, I've got the CLI running in server mode, I've got JSON RPC, so it can be set up. So I debated not even mentioning this, but it is a scenario, it is a solution, right? And I've found it to be kind of useful. You can integrate it into web apps. I'm going to show you a quick little demo. My quick little demo is a real world problem for me. At work, I help handle a bunch of different things like writing a newsletter. So every week I send out 2 different newsletters to 2 different groups about here's all the stuff we released in VS Code and here's all the stuff we released in Copilot CLI. Now all this information just comes from the change logs, from blog posts, etc., a bunch of feeds. But people are busy. They just want a TLDR. Give me the top things. Summarize it for me, right? They could run a Copilot query. They could ask somebody to summarize it. In this case, they asked me to do it. I don't want to do it, so I wrote a program to do it, right? So here's my little console app that grew a little bit. Let's, what do we want to hear? What's the latest in VS Code or Copilot CLI? Any choices? VS Code, let's do it, okay. So here I'm picking my model. I'll do Claude Opus 4.6. I have a caching system. Again, always good when you're thinking of AI. Tokens cost money. If we've already summarized something, no need to summarize it again, right? So we'll do for the past 7 days. Then it says confirm it. So here it's going through. It pulled all those feeds. Now it's generating content. So this actually is kind of this interesting multi-level, multi-layered thing where first of all, it summarizes each release. The release notes have tons of things like bump this, reverted, change that, shipped amazing new feature, oops, reverted feature, like all this different stuff, right? And nobody wants to read all that stuff. They just want to read the actual, like, the actual newsletter, what actually shipped, right? So we first summarize the releases, then we summarize, and then we build up. And up at the top, we need a TLDR, couple of word summary, or a couple of sentence summary, and then above that, we want a title. Now, when you picked Copilot, they didn't actually release as much. Normally, this is a few pages long, right? So this is summarizing just some stuff in blog posts because their release comes out later in the week. This actually runs super fast, so I'm going to run this again, and we'll do it. I should have thought of that. We will run this for Copilot CLI. Those guys are crazy. They release like probably 3 times a day. Okay, so let's do Copilot CLI SDK. I always do Opus 4.6. That's my lucky model. Okay, 7 days. So it pulls all this stuff, pulls the feeds. So first it summarizes news and announcements from blog posts. Then it summarizes the project updates. Those come from release notes on GitHub. Again, those are the noisy ones, and sometimes they ship like pre-releases, and sometimes they duplicate things and all that. So these project updates, it creates summaries for each of those, and then it does a roll-up. Here's what we shipped this past week in CLI. This is what we shipped in the SDK. And then it creates a welcome summary summarizing all that, and then it creates a title summarizing all that. Then I paste this into the newsletter because they don't have support for that yet, although I'm working on them. Okay, so now if we go to, here's the Copilot CLI SDK, right? So here's all the different things. So it's summarized down at the release note level, right? So it's went into the release and it said, here's the summaries. It gives each one like a nice title. It's like strips out a bunch of stuff, right? So if we look at the code for this, I went a little nuts on here as I do. Let me see, source. If we look at our program, so most of this is noise because I have all these different modes and all this stuff that we can run. The actual code is like a few lines and it says like, do it, you know? Here, let me see. Prompt. So we look up the different models, we select the different things, select the days. Oh my gosh, this is 90% like, let me look at my actual sample here because this shows the thing. If we do create session async, so let's look for that. It's not even in this file. I think I abstracted it. I know I always do this stuff. It's in one of these. So the point is, I totally just vibe coded. I told Copilot to build this for me, and I said use this SDK, and it just totally built it. So the example here is, I'm not running this in production. I do want to like do something quick and simple, but I don't want to just run the same like prompt script every week, right? So this is an example of that. Create session. There it is. Async. There we go. So here's my newsletter service. Amongst all the random noise, we're just creating this session. We're setting some different things. For instance, deny unexpected permission requests. You have some other things. I'm using streaming mode. I'm setting the reasoning effort because I don't want to waste money on specific things. So the actual like roll up is really pretty simple there. Here's an example in code where I said, here's how to create this summary, right? And so I tell it things. You're a technical newsletter editor, writer, blah, blah, blah. You're writing for developers. Don't say things are groundbreaking. Don't talk like a marketer, like that sort of stuff, right? So anyways, this is an example of something that I've built. We've got some like samples in the recipes if you want to learn more. So that's in, if we go to awesome Copilot, and it's in these recipes. So we've got these example recipes for things like PR visualization, managing files on your computer, that sort of stuff. So this is great for scripting. This is great for developer scenarios. It's also, like I said, Copilot wrote that thing for me because I said, go, look at the docs for Copilot SDK and build me a newsletter generator. And so does that kind of make sense? I wanted to we're starting, we've got all the building blocks. Now we're going to go a little deeper with a more complex building block. This is model context protocol. So up till now, we've been telling large language models to do things. And then they go and do a simple task. Over time, that's evolved. We started with RAG scenarios where we want large language models to ask for information. But what if we want a large language model actually like do something, like go out and make a change, work with an API, build something, like do something that's really specified, but also we want it to be deterministic. We don't want it to just run, because when large language models, the way they work, they have this thing called temperature, which is a bit of randomization. That's why when you ask a large language model the same question over and over and over, it's different every time, right? It's hopefully pretty correct, but it's different every time. So that's this random element that's thrown in. Well, if I tell it, hey, I want you to create a .NET project and I want it done like this and this, I don't want it to get too creative, right? So we want to be able to kind of constrain, and we also want to, again, I'm a cheap person, we want to save money in cases where we don't need imagination and generation and token spending. Okay, I've got a really good example of this in a second that'll kind of connect that together. The general idea is you can have a host app. It's calling into, it's got a client, like say Visual Studio. So my host app is Visual Studio Code. It's got this client inside, and then it's got multiple different things it can call into. It could call into, say, a weather service. Okay, a large language model could maybe query the internet and who knows where it's going to search and all that. Or I could say, here's your tool. If anyone ever asks about the weather, call this tool. And the tool actually just runs a query and parses the data and returns it. Okay, and then the large language model says, I know what the weather is, here's the weather, right? We could also have something that queries a database, looks up your products, updates an order, that sort of thing. Then you get into the thing of like, hey, we need permissioning, which there is a model for that. Now, here's another cool thing. We have MCP servers at Microsoft for searching the Microsoft docs. So there's the Microsoft Learn SDK. It's indexed several times a day. So if you ask a large language model, what's the best way to do this in .NET? It's going to guess based on random stuff it read on the internet and was trained, right? If you point it at an MCP server, the MCP server has the exact definitive answer. It says, here is how to search that in the docs. But look on the Microsoft docs, look in this section, here's blah, 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 right? So we've built a query tool for that. So MCP servers are really useful for doing like constrained, focused, solve problem sort of things. Now, there's another thing called skills, and skills kind of muddy the waters a bit. MCPs, often you think of those as wrapping like an SDK or a REST API, that sort of stuff. A skill is more sort of like a script where you're giving an MCP like, if you've used custom instructions, you can give custom instructions and they can be at the repository level and they can say, this project is about this, here's how we do this, here's how, when we build tests, here's how I want them to look, always format things this way, that sort of stuff, right? The problem is my custom instructions got huge. And those custom instructions actually are part of that system prompt. Remember when we were looking back at our telemetry for our first thing, and we asked just a 3-word question, but then there's a system prompt at the beginning? So if your system prompt is huge, that is part of your overhead. That's your context that's going back and forth every time. So MCPs and agent skills both were ways of kind of solving some of those problems. Now, MCPs are focused on like running code, doing, like definitive things. And then skills are more kind of like that decomposing your custom instructions into specific things. Here's how we run tests. Here's how to do this. I'll give you a funny example. I've been playing with writing fiction using Copilot. I created skills for things like a historian, a customer, or like a voice, like make sure that people speak the way they should speak, a continuity expert. Like those are examples of skills, right? Okay, so there's a C# SDK. The MCP C# SDK is a way of wrapping, it's a way of writing official MCPs using .NET, and it handles all the important stuff. So you can use annotation, you can use you can like it just kind of wires all the stuff together in a way that makes it just look like normal .NET code. So an MCP server is normally just like basically a console app running on your machine. It can support all these other features, but at the root, it's basically like it exposes tools. The tools have annotations that say, I'm a tool, I'm a tool, I'm a tool. And those things are just a function call. And the large language model knows how to call into it. So building, here's what I was saying there. You're building a thing, and you're saying, I'm a tool, MCP server tool. You give it a title. You can give it an icon source. You can give it a description. The description should, so that description is actually of the parameter city name. But you should actually have like / comments that say what the tool does. Because that's how the large language model knows how to call it. But so now, if this tool was hooked up, I could ask, hey, do I need an umbrella today? And the large language model would say, oh, the person's asking about the weather. Do I have a tool that can answer that question? Yes, go get the weather, 72 degrees. Then it, reasons about that, and it says, no, you don't need an umbrella. So here's my real world example. I wanted to build something because I like building stuff, and I also wanted to kind of understand this in more detail. Also, I got frustrated when I was building apps using large language models in .NET because it would just guess wrong. Like it would build project files by just creating the code based on things it had seen on the internet, right? And it would just kind of make all these guesses and stuff. Well, when you write a .NET app, do you just start writing XML and hoping it's right? No, you use .NET New or you use File New, right? You use project templates, right? So we have a structured way of solving a problem that also spends no tokens to do it, right? We can create a project using no tokens. So I hacked away. I've spent months on this actually. And I've basically been project managing. I've been reviewing at a pretty deep level, but I've used, of course, Copilot to help write this. But this is some of the stuff it'll do. It knows what templates are available. It has intelligence about which frameworks you have installed, which ones are long-term support, short-term. It understands error codes that it get back from .NET Build or from NuGet, handles secret redaction, all that sort of stuff. So I think this is pretty cool. So I'm going to show that off. So here I've got, this is my .NET MCP. First thing I'll point out is I use a ton of tests when I'm building using Copilot. So there's, I think, 1,000 tests in here. And then I have a release gate that exercises a bunch more, runs on Windows and Ubuntu, and it takes, it does all kinds of stuff, creates projects and all that sort of stuff. The cool thing though is if I'm actually creating, so if I look at my program, it's gonna look like, a standard .NET code. It does do some things like expose server info. It does some things like, well, let's go and look at a tool. So if we go to our, let me see. Yeah, tools, thank you. Go to CLI. So here's the MCP server tool type, right? And then you'll see a lot of these tools, if I scroll around a lot, there's going to be tools like this is for metrics. You notice here we use // and that's because the MCP C# SDK actually uses a source generator that turns your / comments into the document, into the way that that the MCP format knows to look up a tool. So actually, just by doing this, building, releasing it, then it's able to say, okay, here's what this tool does. It helps with tool selection, right? So we're going to try in here. I think I've got this installed. Let's go to there. So I've got this installed. If we look at the JSON for it, so these are the kind of lines of text. all right? So you can install things out of the extensions in here. There's no files in here. I've got this called brand new app. I just published a new version this morning. What can go wrong? All right. So it's advertised 12 tools. Now, when I originally built it, the naive thing is to just keep adding tools. I got to over 70 tools. The problem is that adds to all that context. So what you really want to do is have very focused tools that can branch out. So I have like a project creation tool that has like enums and different settings. So let's try this live demo. Keep it exciting. Say create a new web app in the latest LTS with an X unit test framework. It's misspelled intentional. And MTP, kind of intentional. Okay. And be sure to use, actually I want to call, I'll do web API. I know we're not supposed to anthropomorphize, but I picture Claude as like the friendly kind of professor, that's going to help you out and kind of give you guidance. GPT-5 is like the sergeant or whatever. He's like in Halo and he's like, sir, yes, sir. But then he's like, like Claude's like joking around with me and everything. And GPT is just like, executed. You have not given proper guidance, like, okay. All right, so it is going and doing stuff. It's saying yes. Now here's an important thing to know about MCP is there's this permissioning thing, right? So it's saying, do you want me to run the tool? So I'm going to say in this session, go ahead, you have permission to run MCP servers in this session. Task list SDKs, unknown error, that's great. There you go. Well, I have two machines, so I'll switch to the other one. Tools loaded. Oh my gosh. So I've got other stuff I need to show. I will just point out though, because it's been pretty over the past few months I've built with it, and I'm like building tons of stuff, and it's really cool to be able to like very quickly like wire stuff up. And there's tons of features that are all supported by the C# SDK, like resources and things like that. So you can say like, it's able to query intelligently about like, what are all the projects in this solution, that sort of thing. But I do need to get on, I got 10 minutes left, and I do want to get into the multi-agent stuff a bit more. So we've been kind of building things up. We've been talking about making like a specific thing more intelligent. What is still lacking though are things like context. Remember I said like context is expensive. We're lumping things in and it's building up that context over time. So we need a way to manage that context. We've talked about like MCP for tools, and there's different ways for that. There's different, the model is kind of the building block at the beginning. Lumping that all together, then we get an agent. So this kind of progression, we start with this retrieval, which watches do you have? Then we can do some generation on top of that. I showed you like with the newsletters, generating summaries, right? Then we can do actions, and that's like that MCP that I showed. This is something where it's actually building a project for me, running tests. The last step of that is multi-agent. This is orchestrating multiple things to work together and doing that intelligently. That intelligent way of orchestrating them together is important. It's hugely powerful. It's great to have sub-agents spin off, have focused specialized agents run. It's also introduces more complexity, and it's also possible for things to go wrong. If you have an unintelligent, like just a crowd, and you say, hey crowd, go do this thing, they're all going to overstep, they're going to break each other's things and all that sort of stuff. The Microsoft Agent Framework is, we had a question earlier about like semantic kernel, autogen. We've had like a lot of people at Microsoft building. So they kind of focus all the efforts on Microsoft Agent Framework. So the idea is, building off of standards like MCP, et cetera, integrated in with research, all these sorts of things. This last thing, ready for production. So they just hit release candidate. That means that the API is locked, and so you can build on it now and anticipate a GA pretty soon. Microsoft sometimes has conferences around this time of year, so that's something I would think about too. So yeah, this is a general thing, combining all the great stuff, that was kind of separate and you had to piece together in semantic kernel and autogen, building off of, you'll see that kind of bolded there, iChat client, the ASP.NET hosting model. So they support Python, they also support .NET, and the .NET stuff is very closely integrated in with, it's built on MEAI. So you get all this sort of stuff, graph-based, so for constructing things, human in the loop, very important. So having a bunch of agents do things is neat, but you actually need to control what they're doing. Streaming, dev UI is awesome. Observability, okay. So as an example, here is creating something. You say, so we create an iChat client, and then we can just say as AI agent. You can hook up multiple things. So here's an example. We'll look more at a specific one for interviews. So this actually is built. I've got a better architecture diagram in a bit, but the idea here is like interviewing things and having somebody that's just a technical expert or just a summarization expert. Now, a technical expert, you may need a very high-end model for something, right? It may need to be trained on something, may need to have access to technical resources. Summarizer doesn't need that. Summarizer can probably be a low-end model and doesn't need access to things. So you can control your permissions and access and all those sorts of things. You can integrate with MCPs also. So this is, I showed you like an MCP as a tool that can do a specific thing, can run a task, query a database, something like that. So we can hook that in to a multi-agent flow. All right, so now let's look at Interview Coach. So this is what Interview Coach does. We have a Blazor front end, uses this thing called AGUI. This is Agentic UI. So that is a common community standard pattern for writing user interface things that work with, like we don't all need to write the same chat UI thing over and over, right? But there's other things we write for building with agentic stuff. There's this agentic framework backend. Then we have so ours, we're hosting ours off of Azure, but you can run this locally. There's different ways. This is a reference sample. I'll show you the code link for this in a bit. So first, a query comes in. We have a triage agent. What is this? Who gets this question? Who should deal with this? The idea here, this is for running technical interviews for a job. And so first thing, probably go to a receptionist. Then we'll go to, behavioral interviewer. Like, hey, do you show up for work? Do you punch your coworkers? That sort of stuff. And then your technical interviewer is going to look at those technical questions, and then we'll summarize it all. And then we don't want to keep all this data floating around in context, so we have a SQLite backend. And then we've got this Marketdown server. Marketdown is an open source project from Microsoft, runs with MCP. That's that little logo in the top corner, that's MCP. And so that is an example of running code that turns something into Markdown. So in this case, we've got PDF files or HTML or Word or something, and you can turn those into Markdown. Here's what that UI looks like. I'm not sure if I'll get time to show you the dev UI, so I'm just showing you this, but that's what that dev UI looks like. So here's our interview agent. So the default way of running is with LLM handoff, which is where it uses that cast of characters. There's a switch in here where you can say, just run as one chat, and the results are a lot lower quality and also more expensive. So I'm just going to go ahead and run this. And as I run it, I'm going to get my, okay, so we got some fake resumes and job descriptions. So that'll come in handy. Let's go with Peter Parker. We're going to go with this interview coach. So let's go to the web UI. Want job resume is here. And job is this? Cloud Solution Architect. I don't know. I think you can pull it off. Okay. So those are both PDFs. That market down server that we saw in that upper right hand corner is able to read those. So so the query comes in. And the first thing it's going to do is come to the receptionist. The receptionist will say, first a triage agent that says, what do we do? It's a new question. Okay, first come to the receptionist. The receptionist is going to welcome us, and then it's going to kind of go through that flow. I'll let it, as it's doing that, I'm going to kind of wrap up with my other slides. So this is the dev UI. This is a standard dev UI that you can bring up, and it'll show. You can actually click on things that'll animate. You can, just like we looked at before, like you can look at, here's the query that's being run, all that sort of stuff. Aspire dashboard. If you want to see over an hour of this, there's a thing just, I think last week. So this is Justin Yu and Bruno who wrote this. Justin was the main author, and then Bruno hosts this .NET AI community stand-up every Wednesday, which I highly recommend. This is on the .NET YouTube channel. So they kind of went through this in depth. So you can see the going deep into the code, et cetera. So I want to just pop back over real quick and see if it answered it, because that's fun if it does. Great, okay. No time, just hire me. Okay, so trying to think of anything important on wrap up. Well, let's look at the code in here. So we have this this sort of thing. The agent framework code is what I wanted to look at, and the agent framework code in here is in this program. Actually, no, that's in here. I had it open. So you have like your different resource factories. Gosh. Honestly, with a couple of minutes, it's not going to be worthwhile. What the main things that are happening is there is it goes through and it constructs. It says here are your different agents. It gives each of the agents a different prompt, so a different thing that they can do, and then it goes off and says, okay. Wire that all together with agent framework. And agent framework is where those things are all composed together. And so I'll let you, if you're interested in that, that's the kind of next step. Let's see if we got the job. I can start right away. Okay, so we unfortunately have to go through a hiring process. But quality and governance. Do remember to think about this. You can unit test AI. So there's Microsoft extensions for AI, things for data quality as well, for evaluations. So you can run unit tests, you can run all this stuff. So that's important to do. And basically you can have your canned stuff, just like you would do with any other unit test. You can say, when I ask about this, give me this answer. When I ask this, make sure this MCP was called, that sort of thing. And also make sure that these, quality and safety and all those sorts of things are included. Here's my list of references. I'm at time. Thanks much.